I'm having a little trouble here, guys, so hang on. Guys, can anybody hear me? Everybody seemed muted. Somebody tell me if you can hear me, because I'm not seeing very well today.
Yes, I can hear you.
Wonderful. Okay, good. I've got my screen already shared. There was a glitch yesterday. For some reason, the video did not work. So what I did is I've turned it to the recording to come on automatically and just stay on every time. So that's what I did in the place of that, guys, was host my lecture. Unfortunately, the things I wrote on it were not there, but these follow a pattern of the ones in the book. So you'll see what problem I'm working in the ones in the book, and then hopefully be able to see what I've done. I tried to get it posted with my markings, but I couldn't. I'm going to work on that this weekend and see if I can learn anything else about Zoom. I'm sure there's I know less than there is to know, actually. So, okay, I'm looking at names right now. I'm looking at Haley, Anai, Bree, Jennifer, Stephanie, and Tori. Okay. All right. Let me wait a couple more minutes and for everybody to come in, and then I'll start talking about another problem or some more problems from yesterday. Okay. All right, 1, 2, 3, 4, 5, 6, 7. I got 7 of us here. Plus me is 8. All right, I tell you what, guys, let's I've got a blank sheet up on the screen share. I'll let people in as they come. And I'll for some reason my video camera's got a cross through it when I open it up now, and I have to open it up manually. I'm not used to that. But let me see if anybody's got questions from any of the homework problems. They were mainly either business kind of applications on all of these things. Is there anybody that has any questions or issues, anything about critical numbers, anything about absolute maxes or mins? I'm going to do a couple more business problems, and then I'm going to do something a little bit new that's not too hard, but it's newer.
Yeah, can we just do more business problems, because I'm not as good as those as everything else.
All right, I'll just go back and do a couple that I didn't get to do yesterday, okay? And we'll talk about what the process is and everything. Anybody else got a comment before I start sort of talking through some of this? Okay, I'm gonna go back. See, I can see what I wrote yesterday on my screen, but I can't somehow, and there's where I was trying to practice my typing with some stupid sentence that they made me type in high school over and over again, but I couldn't remember what it was. That tells you how far I am from high school. Let's look at a couple more of these things. Oh, I don't like that one. Let's look at this one. No, let's look at this one. Okay, here, this is a good one right here. This is basically the one I stopped at, guys. I think, yeah. And this takes care of, this does a lot of stuff. So let's do this one. It will remind us of a whole lot of things that we've got. It says, and I may need your help with the calculator again, so get the calculator close by. Tell me one more time. Can everybody hear me? Is everybody okay?
Yes.
Yes.
Everybody's hearing me? Okay. All right, good. Okay, so I'm gonna see if I can't at least get you. Okay, I can kind of see you now, some of you. Like I see Jennifer's big J, I see Michelle, I see Bree, I see Haley, I see me. I'm tired of looking at myself. I see Stephanie.
So I know you said the video didn't work on YouTube, but is there another way that we could get what you did?
It's not. I can't record. I can't re-record it. I don't know what happened to it. It only got 5 seconds for some reason and then cut off. I'm going to try, here's what I'm going to try to do. This is all I can do. I put the lecture up, the problems that I did up on Moodle. And the problems that I did were ones in the book. Okay, so if you can identify the problem and then look through what they've done in the book, it's exactly what I did. It is without the explanation, but that might help. The other thing is I'll keep trying this weekend when I get a few, remember we don't have class Friday, but when I get a few minutes this weekend, I'll see if I can't do with that lecture what I do with your homework, and that is transfer it over with all my markings on it. That really might help, although it was kind of messy. I was really disappointed when you told me yesterday it didn't go up. Didn't go up.
Would it let you like take a picture of the slide on your phone? And then
I don't know. I might be able to take multiple screenshots, but I will try. But let's just do another problem that sort of carries us through everything, and that really might help. Okay. Okay. So nice dog, Tori. Wow, that's a beautiful dog. Okay.
Thank you.
Is it a golden retriever?
Yes.
Yep. Okay. All right. So guys, let's look at a problem. That's one of these business problems, and it says a business sells 2,000 units of a product per month. Dang. Hang on. There we go. It sells 2,000 units of a product per month at a price of $10 each. It can sell 250 more items for $9.75 each. So guys, what they're trying to do, the question is, write the demand function if the function is linear, okay? So the upshot of this and where we're going with this is that they're going to ask us to write a revenue function. And if you remember, a revenue function is X times the demand function. And then what they're going to ask me to do is find out where the revenue's maximized. So this will carry us through every single one of these processes here, and we'll see what we come up with. All right, so what they give us to be able to find this little P here, which is the price or the demand function, they're, in a sneaky way, they're giving me 2 points. They say a business sells 2,000 units, X, for a price of 10. If it sells 250 more, in other words, 2,250, they're $9.75 each. So they're lowering the price. They're lowering the price when they have more here. So write the P or the demand function if the function is linear. They want a line right here. They want me to write the equation of a line to find out what P is. And I know I can do that because I've got 2 points. So what's the first thing I'm going to do, guys? Tell me what's the first thing I'm going to do with those points if I want to write the equation of a line.
Find the slope?
Yep, I'm going to find the slope. So the slope will be 10. I'm at the second coordinate, the change in the y, which in this case is P. So 9.75. So 10 minus 9.75 over 2,000 minus 2,250. Okay, that's the slope. That's the first thing I need to do to write the equation of a line. We got to, you can't ever forget anything in math, okay? This top is 0.25. So, and the bottom is minus 250. And here's where I need help, guys. Tell me what that is. Get your calculator out. Where's my phone? I'll check it on my phone. All right, get your calculator out.
Negative 0.001.
Where? Oh, yeah. Oh, that's what you got. Negative 0.001. That there's definitely a 1 in there. It's definitely negative. How about it? Is everybody getting that? Can I have some confirmation, please?
Yeah.
Okay, good. There's the slope. So now I'm going to write the equation of the line, and I'm going to use this point right here because it's a little easier to use. The equation of a line, remember, is P minus the P coordinate is equal to the slope times X minus the X coordinate. Okay, remember guys, that was the point slope form of a line. Now I'm just going to play it out and solve for P. So I'm going to multiply this thing out. It'll be minus 0.001 0.001x plus, minus a minus there, but what's 0.001 times 2,000? I think I know, but tell me what you get when you get 0.001 times 2,000. Anybody?
2.
2. That's right. So when I multiply that out, I get 2. Okay? Is anybody not getting that? I think it's 2. And it's plus because we had a minus slope times that minus in there. What that gives me, I'm going to add 10 to both sides so that I can solve for p. So that gives me this little p, this demand function, is minus 0.001x plus 12. There it is. That's the demand function, guys. All right. Is everybody okay on how we did that? Now, there's no excuse for messing up writing the equational line now. You've got the forms in the book. You've got a million examples in your notes. That's what we're going to do. And the hint here, guys, that's what you need to do is that it says if the function is linear. If it says that and they're giving you 2 points, you know you're going to write the equation line. So let's go to the next part. Any questions about that? All right. If I go down to the next part, revenue is XP. So in this problem, XP will be X times, and there's my P right there. I'm just going to plug it in, minus 0.001x plus 12. I'm going to multiply it out and have minus 0.001x squared plus 12x. All right, that's my revenue function, guys. Revenue is X times the price. It's how many you sell times whatever the price is. That's how much money you're taking in. It's revenue. It's not profit, but it is revenue. And many times when we maximize revenue, we'll get lots of profit, okay? Sometimes. So the first thing I want to do after I write the revenue function, and here's where the calculus starts, it says find out where the revenue is maximized, okay? So I'll leave the revenue function up there. If you want to find a maximum or a minimum of a function, you need to take the derivative. So to do this right here, I need to take the derivative and set it equal to 0. And all that is finding the critical numbers, guys. It's the same thing we've been talking about with just plain old functions that didn't have any particular application here. So when I take the R prime, that's going to be equal to, bring the 2 down, it's minus 0.002x plus 12. Okay? So there's the derivative. I'm going to find out where this is 0. Because what you're finding there, guys, just listen carefully, those are nothing more than finding the critical numbers. That's how you find these critical numbers. And critical numbers, remember, are places where maxes, local maxes and local mins can, and absolutes can take place, can be. So I'm going to solve this. I'm going to bring the 0.002x over to the left-hand side, which makes it positive. And there's 12. So I have x is 12 divided by 0.002. Okay, so I brought that over. I got the 12. I divided by 0.002. Okay, somebody tell me what I've got, what I get there.
6,000. All
right, that's right. I get 6,000. Now, let me go. This really should be, is there a question about how I got that? Anybody? This is a critical number. So here's what I'm going to do with it. I'm going to go down here and put that critical number on number line. Now, what it says, where's revenue maximized? Well, this is my only critical number, so I'm pretty much thinking that's the answer, but I'm going to check it just to see. If you think about what the derivative was, and here's the derivative right here. Let me write that down. R prime is minus 0.002x. Oh, sorry. minus 0.002x plus 12. So this derivative here, r prime, is minus 0.002x plus 12. Now, remember, do I have somebody to admit? I don't think so. Okay. So what happens here is that there's a derivative. I need to know where it's positive and negative. Remember that we're producing things, so we really only care. We don't produce negative things, so we over there. And then the book might have given you some limit on this side. It really doesn't matter. But what I'm going to test is a couple of these points. If I test, for instance, 1, and I'm always testing in the derivative to find out where it's positive. That tells me increasing and decreasing, okay? So I'm going to test the x equal 1. If I plug in 1 to the derivative, I get minus 0.002 times 1 plus 12, and it's pretty easy to see there that you would get a positive number. I don't really care what it is, but 12 minus 0.002 is definitely positive. So I got positive. That tells me that over on the left, my revenues are increasing. My revenues are increasing. All right, tell me if you don't understand what I'm doing, because this is the heart of what I'm doing. And it's basically, if I do this problem, it's pretty much everything you were going to do yesterday, everything we did yesterday. If you look at another test on the right-hand side, let's test 7,000. So I'm going to plug it into the derivative. So minus point, let's see what I got. Get Michelle back. Okay. I'm going to, hang on. I'm going to test that 7,000. It's going to be minus 0.002 times 7,000 plus 12. I want you to put that in your calculator and tell me what kind of number you get. You can tell me the number, but it doesn't matter. I just want to tell me what kind of number you get. What's minus 0.002? I'm plugging into this derivative, plugging 7,000 in. Times 7,000. What did you get?
-2.
Okay, -2. Honestly, I don't care that it's 2. What I care about is that it is negative. So on this side, I get negatives. Okay, that tells me that on that side, after 6,000, after we produce or sell 6,000, these revenues start going down. So guys, now talk to me here about what's happening right there. If I'm going up and then I'm coming down, is it the maximum I was looking for?
Yeah.
Yeah, because it's a peak. Yeah, definitely. So here's what I want to do next. It says, what is the maximum revenue? So I'm going to write this the way I would like to see it. It says, well, what I've just found is that the revenue, right, which was R equal, let me go back and pick it up, guys, which was R equal minus 0.001x squared. Ugh. Minus 0.001x squared minus 0.001x squared, and I can't remember my name most of the time, and what's that going to be? The revenue was plus 12x, I think. Plus 12x? Yeah, there was the revenue function right there before I took the derivative, okay? So there is the revenue function. So here's what we're going to say. We're going to say the revenue is maximized. The revenue is maximized when 6,000 of these, whatever they are sold or produced. When 6,000 are sold or produced. Okay, whatever. That's what your X is, guys. So if I want to find what the maximum revenue is, what do I do with the place that it occurs? What do I do with that, guys? That, plug it into what?
The original?
Yes. Good, Stephanie. That's the original, okay? So here's what I'm going to do. That means the revenue is maximized when 6,000 are sold. And I will say the maximum revenue is, the maximum revenue is the revenue with 6,000 plugged in. I'll use my functional notation here. That's minus 0.001 times 6,000 squared plus 12 times 6,000. I need help again. Somebody get on the calculator. That's a zero. 6,000. Tell me what the revenue is at 6,000. Wait till a couple people get it.
I got 36,000.
Same thing.
Anybody else get 36,000? Did I hear somebody else?
I did
Yes.
too.
Okay,
Yeah,
good.
I got 30,000.
Perfect. Okay, so that says that the maximum revenue is 36,000. Now, let me just tell you, you weren't asked to graph this, but let me just tell you so you know what's really going on here. And I'm going to draw just a really rough graph where I'll put a axis down here. And normally, guys, if I were in my own classroom, I would do a better picture. But at 6,000, we get a point on the graph. This is revenue up here. This is produced things down here. So the point I get on the graph, you guys just told me when I plug 6,000 in, I get 36,000. Now, what we know from our little sign chart here was that it was increasing to the left of 6,000 and decreasing to the right. So when I draw this picture, I know what it's going to look like. The revenue's zero when I produce zero things. So there's another point I can put on there. It goes up until it reaches that point, and then it goes down, increasing on this side, decreasing on that side. Okay? Increasing and decreasing. And it happened at 6,000. Now, there's one other thing I can ask here. What you really want to know when you're making these kinds of decisions is what price should you charge to make this revenue maximum? Now, remember that the price function up here, if I go back and look, the price function was minus point, that's the thing I got from doing the 2 points on the line. So minus 0.001x plus 12. Minus 0.001x plus 12. So if the maximum revenue happens at 6,000, then I can find out the price I should charge by putting that 6,000 in there. That'll give me the price at that level. So little p, and guys, this is often called a price. I like to call it a price function. The economists are going to scream at me, but it's a demand function, okay? That'll be minus 0.001 times 6,000 plus 12. And what's that? What's that?
6.
6. They should charge $6 for that revenue. I mean, for that to get that maximum revenue. Now, interestingly enough, if I went back to the original, notice, well, I'm way beyond the original, sorry. Notice that they told us that when the price was $10, they sold 2,000. When the price was 9.75, they sold 2,250. So it was going up as they dropped the price, which makes perfect sense. Demand curves are negatively sloped. What I found is that if I go up to if I charge $6 for these things, I can sell 6,000 of them. Now, if I drop the price any lower, I'm on the downside of the curve. If I drop it any lower, I'm not going to be able to cover my cost or whatever. Anyway, I'm not going to maximize revenue. Okay, so that's what that tells me. Okay, so guys, does that help? I hope it sort of tells you what you need to do in all of these problems. Does anybody have any questions on that one? Let's see if I can find another one. So that takes care of everything, the graph, the writing the revenue function and so on. Questions, anybody? All right, I'm gonna go, let me do one more here. I'm not gonna do that one. I'm not gonna do that one. Which one am I gonna do? Let's look at this one. Average cost. What we want to do with cost is minimize cost, okay? So the question here, and average cost, by the way, is denoted by this, this C with a bar over it, guys. That's what that says. It's got the bar over it. And the way you find average cost is you take your cost function and you divide it by X. It's sort of averaging out what your cost is over a number of items, however many items you're interested in. So the question says, find the production level that minimizes the average cost per unit, where cost is that. Where cost is that. All right, now, in order to do this problem, since they're asking me to minimize average cost, I need to first of all find the average cost. Now, this is good for a business to minimize their average cost per item, because it means it's costing them less to produce things, and then they can go out and sell them and make more money. So I'm going to write the average cost function first. So what it looks like is C prime is 400 plus 0.05x plus 0.0025x squared divided by x. See that? It's cost over x. Now, I need to simplify that, because you know what? If I want to minimize a function, I need to take its derivative. And I do not want to use the quotient rule on this thing. If I separate things, it'll be much easier. 400 over x. This is a common denominator, guys. 0.05 over x is just 0.05. And this thing over x is 0.0025x, because x squared over x is just x.
So what is this finding again?
Say that again, Haley.
What is this finding again?
This is finding average cost. What's their,
Okay.
if they produce a whole bunch of items, what's their average cost per item? Let me say something to you here. If you don't produce very many items, the cost of producing them is high. But if you're set up and you can produce a lot of items, your average over the long run goes down. So the more items you produce, to a certain extent, will keep your costs down. You know, if somebody said, I want you to produce 1 tank, that's going to cost me a heck of a lot. But if I set up to produce the tanks and I produce 400 tanks, then the average cost comes down, because I would divide the cost for 400 by that 400. Okay, so instead of costing me $3 trillion for one, it might cost me a $500 billion if I do 100 of them. Okay. All right. So so here's what we had to, in this particular problem, we were given a cost function, and we want to find average cost. So I divide by x. So you divide by the number of things you do. I'm going to divide by 100 tanks instead of 1 tank. And when I divide that, I get this. And I need to differentiate this. So guys, because that's how I find maximums and minimums, and I want to minimize average cost. So I need to rewrite it. Somebody pipe in and tell me how I need to rewrite this first thing. It's 400 over x, guys. How do I need to rewrite it?
400x to the negative first?
Yes. This one doesn't need to be rewritten. This one doesn't need to be rewritten. I'm in good shape there. So now, in order to find out where it's increasing and decreasing and what the critical number is, I need to take the derivative. That's what the derivative is for, okay? So when I take the derivative, I'm going to get minus 400x to the minus 2. So I just use the power rule on that. The derivative of 0.05 is 0. And the derivative, guys, what's the derivative of 0.025 times x? 0.0025 times x, sorry. What's the derivative of that last term there?
0.0025.
Yes. Remember, it's less, this is like x to the first. When you bring it down, you get an x to the 0, so it's 0.0025. Okay. Is everybody with me on the derivative? Probably going to run out of room here. Maybe not. Okay. So I need to find out where this thing is 0. I am now finding, guys, the critical numbers. That tells me where there might be a max or a min. I am now going to try to find the critical numbers. I do that by setting this thing equal to 0. And I don't, the truth of the matter is, guys, here, that where most people make their mistakes in these problems is not with the calculus, it's with the algebra. It's not building the house, it's using the hammer, okay? That hammer is algebra, and you got to use it right or your house isn't going to be worth a flip after you get it built, okay? So, somebody give me an idea. What do you want to do to solve this equation? What might work? Tell me what might work here, guys.
Could you minus the 0.0025 to the other side?
Okay, I could move that to the other side. Haley, I am going to make a little bit of a thing that might remind you that it might be easier. Since this one is already minus, why don't I move it to the other side and it'll become positive? And then I don't have to worry about that. But it's fine. If you move the 0.0025 to the other side, it'd be a negative. And you'd have to end up dividing through negatives. Do you see what I'm saying, Haley?
Yeah.
Okay. So that's going to be 400 over x squared equal 0.0025. Excuse me, guys. So anybody want to tell me what the next step is in trying to solve this equation? I don't like where that.
Since you already have an x squared, couldn't you just find like a common denominator for the 0?
Okay, yeah, you could do that, but you know what?
Can't you just multiply by x squared?
Actually, I kind of like that idea. You could find a common denominator, but I think you'll be doing extra work, and we'll do it, but I think you can clear out the x squared. Let's do that. Let's just clear out the x squared. And if I multiply both sides by x squared, then I won't have to worry about it in the denominator anymore. And I won't have to worry about finding a common denominator. So I'm going to clear out the x squared by multiplying by both sides. Multiply by both sides. Okay, so if I multiply x squared times that side, x squared times that side, on this side it cancels. I'll have 400, it's 0.0025 x squared. It gets just a little messy here, guys, but I can make it look a little better if I will divide by 0.0025. And that'll tell me that x squared, since it cancels over here, help me with the calculator here, guys. What is 400 divided by 0.0025?
160,000.
Okay, I'll buy that. Is everybody good with that? Let's just use.
Yes.
Yeah.
Yes, we're
Okay,
good.
All right, I'm really close here, guys. What if I
Put another 0.
Say it again?
Put another 0.
Oh, was it 16,000 or 160,000?
160,000.
Oh, sorry. Thank you. Yeah, let me try that again. Let's do this. Okay, is it 160,000 that people got? 16,000. 160,000, is that right? Okay. So, I'm close, guys. What do I need to do to find x?
Square root.
Yeah. Let's take the square root of both sides. So x, and I'm not interested in plus or minus here because we're talking about items we're producing. What is the square root of 160,000?
400.
Nice. Okay. All right. Any questions about the algebra? Now, I will address guys, let me see how much room. Shoot, I'm running out of room.
Do you have to do like plus 400 and then minus 400 since you take the square root?
Well,
or no?
Haley, that's what I was saying. We're in the context of a business problem here where we're producing things. And since typically I would pound you in an algebra class if you didn't put plus or minus there, okay? But we're producing things that we don't produce negative things. So I just take the plus part. Does that make sense to everybody? So I'm not withdrawing my rule. I'm just saying that my rule is in this context is irrelevant. Okay, I'm going to take the plus one. Now, here's what that says. Let's see what we got here. What that says is that the critical number is 400. The if you want to find out, here was C prime right here. C bar prime, the average cost. If you want to find out whether this is increasing or decreasing, plug in values on the left and the right of this. Okay, you can't plug in 0 here because it would make it you can't plug in 0 here because it would make it undefined. But suppose you plugged in 200, guys. That would be over on this side, and we're gonna say we're bounded on this side by 0. Okay. If you plugged in 200 into, well, actually, let's make something easy. What if I plugged in 10 here? Does everybody see where I'm got the cursor? If I plugged in 10 there and squared it, it would be over to the left of 400. That would be 100 minus 400 over 100 is minus 4 plus 0.0025, and that is clearly negative. But I'm just picking a test point. I'm just picking a test point there, guys. And I picked one. You got to be smart when you're doing this, and you can save yourself a lot of time if you're smart. Don't pick 350, because when you pick 350, geez, you got to square it, and then you got to do the calculator work on it. Pick something easy. So if I pick 10, it's just 100. I can do that in my head. I don't have to do that in the calculator, okay? Okay, on the right-hand side, that being said, on the right-hand side, it's going to be a little harder because there aren't any really nice numbers over there. So suppose I plugged in 500 over here. Now, I'm just picking a test point and plugging it into the derivative right there, guys. So if I put minus 400 over 500 over 5, I'm having trouble writing here, 500 squared plus 0.0025, I think you will see that I'm going to get a positive. Now, what's important about that is this. On the left, it's decreasing. On the right, it's increasing. What does that indicate to me there when I've got decreasing on the left and increasing on the right? I'm sorry I'm running out of room here, guys, but what happens there?
Minimum?
It's a minimum. That's a low point. That's exactly what I was looking for, guys. Let's go back up here for a minute. What that says here is, I'm going to put it, let's see, let me do it this way. What that says in this problem here is the following. It says that a production level of 400 units, a production level of 400 units, a production level of 400 units. I can't write lately. Okay, 400 units will minimize average cost. Will minimize average cost. Okay. So, and if I said, what is the average cost? Where would I plug that 400 into? I said, what is the average cost? I would just plug it into the function I had down here for average cost. So in other words, the minimum happens at 400. The average cost is whatever I get in here will be the average cost per unit to to produce. Let's just plug 400 into this function for me and tell me what you get. I'm going back to Winston-Salem today because I've lost, I don't have everything I need. So what, plug 400 into this. Make sure you get parentheses around there. I want to see what we get so I can write it down. Pop in if you get an answer so we can see.
I got 2.5.
2.5. Okay. Anybody else got 2.5? Kind of like to have some confirmation here. I also kind of like to find my phone. Don't know where it is. Okay, remember, see what I'm doing, guys, is I'm plugging in 400, 400, doing the numerator, and then I'm plugging in 400. So who was it that got 2.5? That sounded like Tori. Was that? No, it wasn't Tori. Who got 2.5?
It was me.
Okay. Okay. Anybody else get 2.5? Anybody get something different?
I got 2.5.
Okay. I'm happy. Okay. So what that says is that the average cost is 2.5 per unit. So if I plug in the 400, so at 400, the average cost is 2.5. I don't know if it's measured in dollars, whatever. It's costing them $2.50 to make them if they make 400. Now, if you go past that, it starts to rise. If you go beyond that, your average cost is higher. So on both sides. So that's the minimum. That's the low point. All right. Guys, you have any question about that? Let me see if I got anything else here. You know what I'm going to do with my last few minutes, guys? Because of the glitch yesterday, I'm going to go to the beginning of this. And we don't have the benefit of me talking through it, but I will talk some through it. And then it'll be on this video, and that'll help you because we didn't get the video yesterday. How's that sound? Let's try that. So big picture. All of these problems we've been doing have been business problems, things we want to maximize or minimize. We know that we started with 3 functions here: profit, revenue, cost. We know the connections between those things. Profit is revenue minus cost. Revenue is XP. We just did one like that. Average cost is C over X. In this first problem here, and you can look at the details, in this first problem here, it said a fast food restaurant shows its profit function to be that. Okay. What sales level yields the maximum profit? First step to maximizing things is taking its derivative. That's what I did. I took the derivative of P prime there. I got that derivative. Next step is once you find the derivative, find the critical number, which means set it equal to 0. And when I set it equal to 0, I multiplied both sides by 10,000 and got 24,400. You'll see when I go through this that all the steps are exactly the same as the ones I did today. They do not change, guys. I asked what is the maximum profit. That 24,000 was a critical number. I went back to the derivative to test these 2 areas here. The derivative, remember, was this one right here. On the left-hand side, I think I plugged in 0, which, well, that's not true. Let me see what I did here. I don't want to mess this up here. Yeah, anyway, I found the critical number. We got a positive number on the left, a negative number on the right when we tested something bigger than 24,400, that means we had a maximum happening there. That thing right there is a high point. Okay, that thing right there is a high point. Okay, so, and that high point is indicative of this point right here. It happened at 24,400. If I want to find out what the maximum profit was, I go all the way back to P and I plug my critical number in and I get my value for the function. That's what that picture right there looked like. Profits were maximized at this 24,400 level. So somewhere right in there. All right, let's go to the next one. I think the next one I did was profit analysis. The National Toy Distributor determines the cost and revenue for one of its games. There's the cost, there's the revenue. We got to make a profit function because we want to, I think the problem was to maximize profit or look at what profit was and maximize it. Profit is revenue minus cost. Don't forget your parentheses. When I simplify that, I got this thing right here. There was the profit function right there. When I simplified, I got the profit function. In order to find out where the maxes and mins are, I take the derivative. Take the derivative of that thing. In order to find out where the derivative, where that actually is, I find a critical number. That's what I'm doing here. I'm finding a critical number. Okay. You find a critical number by setting the derivative equal to 0. When we set it equal to 0, we got 3,000. Test on the left and the right in the derivative. You'll get positives on the left, negatives on the right. That's a high point. We say a maximum profit occurs there. A maximum profit occurs there. Okay. So we did all the details yesterday. This should help looking at it. You can verify it when you go through it. Test it on left and right in your derivative. Positive, negative, that's what we get. If we want to know what the maximum profit is, we go back to the original profit function and we got $7,200. What this graph looks like is that when you produce or sell whatever 3,000 units, right, there's the X value. The maximum profit is 7,200 monetary units, dollars or whatever. All right, let's see what else I did yesterday. This one, oh, this is the one I talked about, guys, where revenue was this, and I asked you to find what will maximize revenue. I took the derivative, and I came out with this quadratic. I pulled out a -3. It was hard to factor. We talked about the fact that this was difficult to factor. If you cannot factor it, you're just going to have to go to the quadratic formula. No reason not to know it now, okay? Because there it is. So plug it into the quadratic formula, and we would come up with those two roots. Now, let me point out another thing that's sort of relevant to what Haley was asking me about the plus or minus the other day. The critical numbers were -50 and 350 in this thing. When I set the derivative equal to 0, I'm really not interested in the -50. I don't produce minus things. So the 350 is the one I want. Test it on the left and right in the derivative. Test it in this. Test it in this thing right here. You'll get positives on the left, negatives on the right. That's an indication of a maximum. Okay. And then you will get, then you'll get what you need there. Okay, and that's where I started today. I think that'll help, guys. So I've sort of talked over the stuff that I did yesterday. Now, I didn't mind spending another day on the business problems because those are, to me, they're important. It's the applications of this stuff. You're not going to go out on the street corner and somebody asks you to take a derivative of something. So forget it. You need to know the general ideas of how this can be used. There's no new homework for tonight. I will start another section tomorrow. So go back and look at these business problems again and see if you've got the process down. It doesn't hurt to keep yourself organized to write down the steps you're taking. Okay, form your profit function, take your derivative, find the critical number, put it on a number line, test, write those down. what I have found out through this whole experience with having to be really, really organized is that sometimes somebody will tell me how to do something online and I'll say, yeah, I get it. And then they leave and I'm like, dang, I should have written that down. It helps me to write it down. It helps me to write it down. And if I need to look at it, I can look at it and need to know where I go next. Okay, so keep yourself organized. We've got notes all in front of us. We're all going to be successful, I hope. I'm sure we will. Okay, anybody have any questions? Anybody have any questions? Okay, I am going to say goodbye, and I will see you tomorrow at whatever time we meet, 11 o'clock. Okay.
Thank you.
All right, you're welcome, and I will see you tomorrow. Try some of these again, and we'll take up something a little different tomorrow. See you
Okay.
later. Bye.
Bye.
Bye.